Good evening, folks. I'm going to do tonight's homework, and if some of you get a chance to view it before tomorrow's test, that's great. I hope that you do. Okay, I'm going to go ahead and do number 1, 2, and 3. All three of these numbers are equations of parabolas, and we're being asked to find some information about the graph without actually graphing. We're asked to find the axis of symmetry, the vertex, the y-intercept, and whether the parabola opens up or down just by looking at the actual equation. Number 1, A, find the axis of symmetry. The axis of symmetry is found by x equals negative b over 2a. The standard form of a parabola, the standard form of a quadratic equation is ax squared plus bx plus c equals y. The b is going to be 4. So x is equal to the opposite of 4. 2 times a, that's 2 times 1. This coefficient is 1. So 2 times 1. So negative 4 over 2 times 1 is negative 4 over 2, which is negative 2. The axis of symmetry is x equals negative 2. B. I'm going to use that value of x equals negative 2 to find the vertex's actual location on that axis of symmetry. So I'll take negative 2 and put it into the function. Negative 2 squared plus 4 times negative 2 minus 2. When I solve this, I'll get 4 minus 8 minus 2. Negative 4 minus 2 equals negative 6. So the vertex is going to be at negative 2, negative 6. The x value is negative 2 from the axis of symmetry, and the y value will be whatever value comes out of the function when I put in negative 2. So there's the vertex, negative 2, negative 6. C asks for the y-intercept. The y-intercept is the c of our standard equation. It's negative 2. Does this parabola open up or down? The coefficient on the leading coefficient is positive, so this parabola opens up, and we're done with number 1. Number 2. The function is y equals negative 2x squared plus 4x minus 3. We're asked to find the axis of symmetry. The axis of symmetry, again, is found by using this little formula, x equals the opposite of b over 2 times the a. The opposite of b is negative 4, and I already put the a in there. 2 times negative 2. This should be a. That's equal to negative 4 over negative 4, which is equal to 1. The axis of symmetry is going to be found at x equals 1. That's the equation for it. X equals 1. That is the equation for the line that divides the parabola into two equal symmetric portions. B, we take that value of x equals 1 and put it into our function. Negative 2 times 1 squared plus 4 times 1 minus 3. And let's see what we get out. 1 squared is 1. 1 times negative 2 is negative 2. Be careful to do the exponent first. Plus 4 times 1 is 4 minus 3. Negative 2 plus 4 is 2. 2 minus 3 is equal to negative 1. When I put the value of 1 into the function, I will get out the value negative 1. And there's the vertex. The vertex is a point at 1 negative 1. The y-intercept is negative 3. And looking at the a here for this equation, this a value is negative 2. It's negative. It's less than 0. It is going to make the parabola open downwards. You can make an arrow. You could write the word down. Any of those would work. Number 3. The axis of symmetry is found again by saying x equals the opposite of b over 2a. Now, the function here says y equals x squared minus 4. And I gave you a hint that b can be written as 0. So x squared plus 0x minus 4 can be a new equation, but it means the same as x squared minus 4. So the axis of symmetry is the opposite of b. Well, that's 0. And 2 times a, that's 2 times 1. I get 0 over 2. What is 0 over 2? It's 0. So x equals 0. That is the axis of symmetry. X equals 0. The b is 0. So it doesn't matter what the denominator is. 0 divided by anything is 0. For b, we need to find the vertex. Well, we take that x equals 0 value and put it into the equation. Y equals 0 squared minus 4. That's 0 minus 4. That's minus 4. So the vertex is at 0 minus 4. The y-intercept is the c value. The c value here is the constant minus 4. And this parabola will open up because the coefficient of the x squared is 1. It's positive. So this parabola is going to open up. Okay, that's the first 3 problems. Now let's graph. Number 4 is not factorable. You can try to make the diamond and solve it, and you'll notice that it is not factorable. And it might be worth your while to do that. But I'm going to have to graph this to try it anyway. And I'll go ahead and show you. 2 times 1 is 2, and negative 4 goes down here. There are no two factors of 2. 2 and 1 do not add up to negative 4, and negative 2 and negative 1 do not add up to negative 4. So it's not factorable. So we're going to have to use our AOS and vertex and y-intercept method and look for any additional points. For number 1 here, the AOS is found by x equals the opposite of b over 2a. X equals the opposite of 4 is 4. 2 times a here is 2. So it's 4 over 4, which is 1. So the axis of symmetry is at x equals 1. I'm going to put that in to the graph. We are asked to graph, not just find them. We need to actually graph them now too. Okay, so the axis of symmetry is at x equals 1. So the vertex is going to be found by putting x equals 1 into the function. So 2 times 1 squared minus 4 times 1 plus 1. 1 squared is 1. 1 times 2 is 2. Minus 4 plus 1. 2 minus 4 is negative 2 plus 1. Negative 2 plus 1 equals negative 1. When I put the value of 1 into the function, I get out the value of negative 1, and that's the vertex. 1, negative 1. 1, negative 1. There's the vertex. What is the y-intercept? The y-intercept is the C. So the C value is 1. It's right here. 1 is our C value. Now I have a y-intercept of 1 on this side of the axis of symmetry. I will reflect that across. To really correctly graph or sketch a pretty accurate graph, we need 5 points. So we need additional points. I'm going to put -1 into the function, this x value of -1, and I'll get a y value up here somewhere. So additional points are found by putting x equals -1 into the function. I could have chosen x equals 3, 1, 2, 3. That would work also. So 2 times, I'm putting this into the function, 2 times -1 squared minus 4 times -1 plus 1. Now I've noticed some things that students are doing. Don't do this. Don't multiply 2 times -1 and then square it. The -1 has to be squared first, and then you multiply it by 2. So -1 squared is 1. -4 times -4 is +4 plus 1. So 2 times 1 is 2, plus 4 plus 1 is 7, not 9, as some of you were getting earlier today. Careful. So x is equal to -1, and the y value that comes out of the function is 7. So my additional point is -1, 7. -1, 7. 1, 2, 3, 4, 5, 6, 7. Go ahead and make your graph a little longer. I didn't make it quite big enough for that additional point. There's my additional point, and I can reflect it across this axis of symmetry. It's 2 to the left, so I'll make it 2 to the right. And there are 5 points that I can now graph this parabola and sketch it the best I can right there. There's some questions about this graph. Does the graph have a maximum or a minimum? Well, this vertex right here is what we're going to look at. It's the lowest point of the graph, so this graph has a minimum. And its value is its y value of -1. Its value is where does it fall on the y values here, -1. The domain, as we all know, x such that x is an element of all the reals. And the range is y such that y is greater than or equal to that minimum value of -1. So it's greater than or equal to -1. Okay, let's graph number 5. Today we looked at graphing with x-intercepts. It can be a little quicker. This particular quadratic equation is factorable. I gave you the hint by giving you the diamond. So -3 goes on the top and -2 goes on the bottom. And to solve this, some of you are getting so fast at this. Let's see, -3 and 1. -3 times 1 is -3, and if you add it, you get -2. Because this leading coefficient is 1, we can just take the factors directly from the diamond. X minus 3 times x plus 1 equals y. Now the x-intercepts are where x minus 3 times x plus 1 equals 0. So that means that when x equals 3 or when x equals -1, this function will be 0. And we can plot those x-intercepts. Remember, the solutions to the parabola are going to be what give us the x-intercepts. So x equals 3 and x equals -1. There's our x-intercepts. They are the numbers that make this parabola equal to 0, the x-intercepts. And if I want to draw the axis of symmetry, I can see that it's at x equals 1 because that's 2 away from that point, and it's 2 away from that point. So the axis of symmetry is right here in the middle at x equals 1. So this is x equals 1. And there's 2 points we have already. We're going to need to find the vertex to graph this. So the vertex is found by putting 1 into the function. So 1 squared minus 2 times 1 minus 3. is 1 minus 2 minus 3 is 1 minus 2 is negative 1. Negative 1 minus 3 is a negative 4. So the vertex is at 1, negative 4. I put x equals 1 into the function, and the vertex is at 1, negative 4. 1, 1, 2, 3, 4. Now I'm going to need 2 more points. So I can put in 0. Oh, look, we have a y-intercept we could use because we don't have a point here. So let's use the y-intercept of negative 3. 1, 2, 3, negative 3. And we can mirror that across, or reflect that across the axis of symmetry. So remember, you find the AOS first, then we found the vertex, then we found the y-intercept. And now I can sketch the graph. Does this graph have a maximum or a minimum? Yes, it certainly does. It has a minimum. And its value is negative 1, 2, 3, 4, negative 4. The domain x, such that x is an element of all the reals. Y, such that y is greater than or equal to that minimum value of negative 4. 1, 2, 3, 4, yeah. Greater than or equal to negative 4. I asked you here, what is the equation for the axis of symmetry? X equals 1. X equals 1. On number 6, we're going to graph to solve. Now, this is also not factorable. We could try, and that would maybe help, that would make solving very quick. But negative 1 times negative 2 goes here is 2, and negative 4 down here. There are not two numbers that will multiply to give 2, but add to negative 4. It won't happen. The only factors for 2 are 2 and 1, or negative 2 and negative 1, and neither one of those add up to negative 4, similar to problem number 4. So it's not factorable, so we're going to use the AOS method, and then we'll find the vertex, and then we'll find the y-intercept and graph any additional points we might need. All right, so the axis of symmetry is x is equal to the opposite of b over 2a. X is equal to the opposite of b would be the opposite of negative 4. And 2 times a is negative 1. So negative negative 4 is positive 4 over negative 2, negative 2. The axis of symmetry is x equals negative 2. To find the vertex, I put that value into the function and see what y value I get out. So the opposite of negative 2 squared minus 4 times negative 2 minus 2. I'm just putting negative 2 into the function. This becomes 4, but it's a negative on the outside, so it's negative 4. This whole thing becomes 4, but we have an opposite. Plus 8 minus 2. Negative 4 plus 8 is 4. 4 minus 2 is 2. So the vertex is at negative 2, 2. I'm going to plot the axis of symmetry on this graph and the vertex. So the axis of symmetry was at x equals negative 2. The vertex is at negative 2, 2. Notice the vertex is up a little higher here. Is this parabola going to open up or down? It's going to open down because this coefficient of x squared is negative. So this parabola is going to open downwards. The y-intercept is negative 2. So the vertex was at negative 2, 2. And the y-intercept is at negative 2 down here. There's the y-intercept. We can mirror that across the axis of symmetry. We have 3 points here. Let's find another pair. And a nice choice might be negative 1. If we choose down here. So let's go ahead and choose one that's going to keep us on the graph if at all possible. So I'm going to choose -1. So if we make x equal to -1 and put that into the function, we'll get another point. So the opposite of -1 squared minus 4 times -1 minus 2. Well, -1 squared is 1, and the opposite of that is -1. Plus 4 minus 2. -1 plus 4 is 3. 3 minus 2 is 1. So the extra point will be x equals -1, and the y value will be 1. -1, 1 is the point that we just found by plugging in -1. And that's right where it should be. We'll reflect that across the axis of symmetry and sketch the graph. Now, this question here is asking, where are the solutions? Where are the x-intercepts? Well, the x-intercepts are where x is between, it looks like -1, -2, -3. This is -3 and this is -4. So x is between -3 and -4, and x is between 0 and -1. Remember, we're being asked to solve this. We graph it, and it crosses the x-axis, and this is where the solutions are. And these solutions don't fall neatly on an actual integer, they fall between. So they fall between -3 and -4, and they fall between 0 and -1. Okay, that's part 1. I'm going to stop this video and finish the rest of the homework on part 2.